Hi, welcome to the video lecture on measures of center. Now, I know that you've probably seen measures of center before, but bear with me because I think that we'll cover this in a way that you might not have seen before. Okay, so in both a sample and in a population, we might like to know about the center of the distribution. And there are three typical measures that we look at: the mean, the median, and the mode. I want to point out to you that the word average doesn't necessarily indicate that we're talking about the mean. It's a general term used to describe the center. It could refer to the mean, the median, the mode, or just in general, what is the center of the distribution. Okay, so notation-wise, the sample mean is x with a bar over it, and we call it x bar. Sometimes you'll see it denoted with a capital M, but the population mean is this lowercase Greek letter mu. So x bar for the sample mean, mu for the population mean. Those are the two big ones, but I want you to be ready in case you see the capital M for the sample mean as well. Number of observations in a sample is lowercase n, sometimes capital N. But for the rest of the course, whenever you see n in a formula, that refers to the sample size. Okay, symbols in this course are important. Probably, if I were you, I would keep a list. I would make a running list, and because I'm going to ask you to be familiar with those, and the sooner you know them, the better off you'll be. So for the sample mean, this notation, this capital letter sigma with an X, refers to the sum of all the data points. And we know that n is the number of observations in the sample. So x bar is the sum of all of the data points divided by n. And here's an example. I'll let you pause and look at this example if you need to, but I think you probably already know how to do that. The median is the middle number of the data once the data is put in order. If you have an odd number, then you just put them in order and find the middle one. So in this case, 8 is the middle. If you have an even number, then you put them in order and you take the mean of the middle two. Again, I'll let you pause the video if you want to look more in detail at that. Mode is the most frequently occurring observation. Sometimes a data set has no mode. Sometimes a data set has more than one mode. And I'll let you pause and look at that if you want. Let's look at how to do this in StatCrunch. So I have put this data set into StatCrunch already. So that's that data there. To get the measures of central tendency, we're going to go to Stat, Summary Stats, Columns. We're going to pick the variable. And if you see here, it's got just about everything selected. The thing is, it doesn't automatically give us the mode and some other stuff. What you can do is, if you want just certain things, you can hold down the control button and pick as many things as you want. So if I hold down control and select median, and then we'll pick mode, click compute, that gives us the mean, median, and the mode. Okay, and then you can just copy that and paste it into your homework. All right. So let's talk about outliers, and we'll formally define outliers in a couple of sections from now, but for now, outliers just as an extreme observation. So for this data set, we've got a mean of 81 1/3 and a median of 81.5. Let's change this lowest observation to a 7 so that we make it an outlier. So what happens here? The median stays the same, but the mean decreases from 81 to 70. So this is to illustrate an important feature of means and medians. Mean is affected by outliers, but the median is not. So the mean gets pulled toward outliers, whereas the median is not. And that leads us to the question, why, if we've got two different, or three really, measures of central tendency, why would we pick one and not the others? Well, you probably know the mean is sort of the one we use by default. That's because it takes all of the data into account, not just, for the median, it's just about the position of the data. What's the middle one position-wise? But for the mean, you actually add up all of the data and you take that into account. So the mode is the least useful. We don't use it very often. The nice thing about the mode is that you can use it for nominal data. Actually, you can say, the mode eye color is brown, for example. So the other case where for numeric data, you might use the mode for a discrete variable where there's only a few possible values for the variable, like the number of children in a family. So now we're down to the mean versus the median. Because the median is not affected by outliers, if the data is skewed or when there's outliers in the data, that's when we use the median. Incomes are almost always skewed to the right because most people make a low to medium amount, but there's a few people who make a whole lot, a few Bill Gateses in the world who make a lot, and they'll pull the mean up but not the median. And we always want to look for what's going to be representative of what's typical. So if we have a Bill Gates in our data set that pulls the median up, that's going to make it not so representative anymore of what most people are making. So we usually, for the case of incomes, we would use the median instead of the mean. So if you ever see incomes reported, they never talk about the mean. It's always the median, and that's why. So let's look at measures of center graphically. So on a distribution, the mode is going to be where on the x-axis the data is at its peak. The median is going to be where on the x-axis you've got half of the area to the left and half to the right. Whereas the mean is going to be the balance point. The mean is going to be where you would put your finger underneath the histogram to see where it would be balanced. So here's what we're talking about. For this data set, here's the mode. The mode is 1 because that's where the highest point is. The median is 2. That's where you've got half the data to the left and half to the right. The mean is a little bit to the right of the median because that's where, if this were like a ruler and you had pennies stacked on it, this is where you'd need to put your finger in order for that to balance. So here you see that the mean is getting pulled toward this outlier, whereas the median is going to stay there. And in general, that's the way that works. So if you've got a data set that's, well, let's say you've got a data set that's normally distributed. The mean and median and mode are all going to be about the same value. In fact, that's one way that we can see if the data follows a normal distribution, is we look at the mean, median, and mode and we see how close are they. If your data set is skewed to the right, you're going to have the mode being the least value, followed by the median, and then the mean is going to be more in the tail, and then vice versa for left skewed. Okay, so now let's talk about the weighted mean. This is when you've got data that's given to you in a frequency table. So here, this is the ages of students in a college class. You've got 10 students who are 18, 5 students who are 19, 3 who are 20, and 2 who are 21. People want to take a look at this and say, well, that's 18 plus 19 plus 20 plus 21. Add those together, divide by 4. The average, or the mean, is 19.5. But we can't do that for this example. That's because we've got more 18-year-olds than 19-year-olds, more 19-year-olds than 20-year-olds, and more than that of 21-year-olds. So we need something to take that into account. Okay, so we need to take into account the fact that not all of these should be weighted the same. So here's what we do. Here's the formula. You take every X, in our case that would be the ages, multiply by its frequency. You sum those up, and then you divide by the total frequency. So for our example, we're going to take every X, multiply it by its frequency, and we get these values here, and you can double check my math. Add up both of those columns, and then we divide the total X times F divided by the total F, the total frequencies, and we get 18.85. Okay? So that's how that formula works. Here's why that formula works. So if we were to take this data and write it out, we got 10 18-year-olds. So 1, 2, 3, 4, up to 10 18-year-olds. 5 19-year-olds, 3 20-year-olds, and 2 21-year-olds. So if we were to add those up, if we were to try to compute the mean using the regular old sum of X divided by N, we'd write out 10 18-year-olds and add those up. But another way of saying 10 18-year-olds is 18 times 10. Another way of saying 5 19-year-olds is 19 times 5. And here, 20 plus 20 plus 20 collapses to 20 times 3, and here 21 times 2. And we've got a total of 20. We could get that by saying, well, there was 10 of these 18-year-olds plus 5 19-year-olds and 3 of these and 2 of these. And so that's why that formula works the way it does. It's basically another way of saying the same thing we did before, but we're using a different formula just because the data is grouped. So with a similar example, if what you're given is not frequencies, but relative frequencies, and this should say relative frequencies, but you would do it, you do the problem exactly the same. The only difference is that the relative frequencies would sum up to 1 every time. So when you do your X times F, here you get a total of 18.85. The sum of the relative frequencies is still 1. So you still get the same mean of 18.85. So here's another example. So you've got a professor who's calculating grades according to these percentages, and you know what the students' grades are, and you want to calculate the students' average in the course. Well, you can make a table just like what we had before, where you've got participation is an 80, and that counts for 5% of the grade. And I won't go through all of these, and then to calculate the mean, you just do every X, in other words the score, times the weight, the frequency, add those up and divide by the total weight. And so the student's average in the course is 85.65. For the same example, students always want to know, what's my current average? So here's how you do that. And so if you ever want to calculate your average, here's exactly how you would do it. So you don't need to ask me. So here's what the student has so far. And how do we find the student's average? Well, we don't know what the final exam is or the essay yet because they haven't done that part yet. But we can just take the mean of what they have so far. So if we do the x times w's, that gives us a total of 53.35. The weights that they've earned so far are 0.65. And so that gives us an average of 82.08. And if you want to figure out what the student needs in order to get a certain grade in the class, what you can do is plug in x's here. So a score on the final exam of x, essay of x, plug in those weights, and you get an algebra equation that you can set equal to 89.5 for an A-. All right, so that's it for this lesson, and let me know if you have any questions.